Welcome back to lecture number 6 of this research methodology online lecture series by RK University. Now we need to be a bit tech savvy and get an overview on computing in data mining and analysis from Dr. Priyanshu Rathod, Dean, Faculty of Medicine, RK University. Professor Priyanshu Rathod has 20 years of experience in physiotherapy. 3 scholars have completed PhD and 7 are pursuing PhD under his guidance. He has more than 40 publications and has availed a copyright for stroke recovery predictor in 2019 from Copyright Office, Government of India. He has also received Best Paper Abstract Award for Innovative RK Walker in the International Conference Physio Dubai in the year 2016. It's now over to Dr. Priyanshu Rathod. Thank you.
Thank you very much, Professor Dr. Devang Pandya sir. I think it will be a fantastic journey for all those participants since last 2-3 days, having a wonderful exchange, knowledge, and utilizing in a right manner. Once again, myself, Professor Priyanshu Rathod, and I have a topic for computing in data mining and analysis. My students, I'm missing them a lot. I'm sure they must be missing me too. Today we are covering few topics: scientific research and data management, data processing, computing in biostatistics, computing data mining and analysis. As I said that it's always statistics are not a favorite subject of the students. People find statistics very complicated, and as per my experience of last few years of teaching, due to A and B group, lots many people who are not practicing mathematics, not have practiced mathematics, and when they come to the B group based profession, they always find challenge in data calculation, analysis and all. So it was a year 2011 that I realized that we should have a computing support in data analysis and management. And thereafter, the students are very much comfortable. Instead of having a mathematical calculation, rather than better to have a computing support, software support to analyze the data. Research methodology in statistics. I think very much, we brush up our knowledge. There is a multi-channel process, finding the problem, need of the study, support of review of literature, set your objectives, materials, then method, collect the data, result, analyze the data, and based on the result, draw the discussion and reveal the clinical significance for reasoning about it, and it goes for conclusion. This is a very simple process, but it is quite complicated in all the stages. My interest here on a method of data collection, analysis of the data, and extracting meaningful conclusion out of those data analysis. Scientific research process. Data is raw, unorganized facts that need to proceed. It gives the informations. When the data is processed, organized, structured, or presented in a given context, so to make it useful, it is information. Knowledge, know-how, experience, insight, understanding, and contextualize information. It is a knowledge. And the last outcome of any research, it is a wisdom. Applied knowledge, decision making, and application for betterment of society, betterment of mankind, betterment of all of us. One of the most important part of entire journey in research is the data, information. Probably every day, millions of data is getting transferred. And you will not be surprised to know that 1.8 million articles, scientific papers published each year in about 20,000 journals in 2007. Postgraduate dissertations, unpublished research data are overflooding the entire system. One of the status from Scopus, 3.7 TB data stored in content repository, 1.4 billion cited reference exist, 70,000 institutional profiles and 16 million author profiles are on the net. Scopus, one of the 11% of database with Elsevier Scopus. And if you consider that 11%, 69 million records and 21,000 active titles from more than 5,000 international publishers are exist. Not even the articles, 120,000 books and 7.3 million conference proceedings are also exist as a research data. So what is the challenge here? We have information, but challenge is underutilization of research data and information. I want each and every listener try to understand the objective within it. As many as 50% of papers are never read by anyone other than their authors, referees, and journal editor. It is not surprising. It has also claimed that 90% of papers published are never cited even. And the data says that first 5 years, probably 98% of no citation. And may after 5 years of publication, they find enough features. What goes wrong about it? Most of time, people just review the abstracts. Even they don't try for full text. They read abstract, find out some conclusion and do the citation. Even those who have taken a parent article, in case they have read the full text, it is very much important that even have a bird view of thesis. But very, very rarely people, they go up to find out the thesis. So many outcome measures, so many learning batteries are just being used from the internet without having proper study of the reference, but it always remain to the manuscript, full text. As I said that many of the papers are not available. People just go to the abstract and make a conclusion. Underutilization of research data and information. The warehouse, the storage, having more than 82% of data are non-used or under-assessed. Data analyzed, high level of significance. Level of significance always paper 0.01, 0.001. We always tend to keep the confidence interval 95%. Why? Even those studies that's been stored in a warehouse can be reassessed from 0.01, 0.05%. Just lowering the confidence interval 95 to 90%, it's not going to change a major about the quality of the research, but it will add on the value outcome from those study data. I have observed that the number of research, dissertation, theses are just lying in a hard disk. Probably after the completion of dissertation and completion of the thesis, rarely the scholar goes back to and see what is the status of the data. Does the data have any value now? I remember that people just submit the hard copy of thesis. That is the last moment when they submit the thesis after the PhD program to library, and they never ever turn back to see that what about the data it was in past and effect on present status. Retrospective data analysis, it is very much needed. It can save so much amount the funding and resources. It will be time will come that, and already has come, about the big data, the retrospective data are very much important. People are going back, digging and mining those data and identify some future prospectors. Who am I? This is my picture from my last visit to Chennai, and it was a group of people enjoyed. This is called uh, Krishna's ball, probably, if I remember. Who am I? I am not a statistician, neither I am teaching you statistics. Even I do not know how to calculate standard deviation mathematically, but I know how to use standard deviation for my data with help of software. In our time, we had mathematics in our 10 plus 2, but presently, the number of students, those who are in a B group even, they don't have mathematics in a 10 plus 2. It's okay. You don't need to know what is the functioning of the computer rather than the application of computer. The same way, calculation, if it is not able to, we don't able to do the calculation mathematically, but software supports are always help us a lot. My objective is here to reduce the gap between research and statistics by promoting computing for data mining and analysis. And probably next few of our slides, I try to reduce the gap between the research and statistics. I always observe the students are slightly stay away from the statistician. For them, just giving the data, handovering the data to statistician, it is a get done job. Just they wait for the level of significance comes satisfactory. But it is not that. And I'll make sure that end of the session, you will generate the interest in a statistics too. As I said, the statistics play a key role in a research. Statistic and research data. Here I am trying to focus the importance of statistics. The method of statistics must be decided with the methodology of the study, research study. You'll surprise that the statistic method depends very much on your budget also, the need of your study, the objective, variables you decide. Each and every variables you increase, your study become more extensive. You interpret many more result out of it. So method of statistics matters a lot. It will be well before sampling or data collection. Communication with statisticians matters a lot. But learning some statistics methods and skill and application, it is going to help a lot to improve the quality of research. You should know what you want from the statistician. Some of my experience, though I am not good practicing statistics, I learned by some of the YouTube videos and some friends and support of the family. But I observe that to many students, when they do the data collection, they just email the Excel sheet, data sheet to the statistician and tell that I want to find out the level of significance. I want to find out this is a result. And most of time, it's observed that they want to have some kind of bias when they forward the data. And many times, some of the fruitful result, fruitful information, incentives from the study, they missed out of it. No doubt, statistician is well capable, but he may not be knowing your research. He may just take the data as a raw material and he craft what he understands. But if students or researchers learn some of the basic principle of statistics, it helps a lot to draw the appropriate result out of your data. We'll have a small example of sample size calculation. One of the most common question of the students or researchers, how to decide the sample size. How to decide the sample size. And you have hundreds of different thoughts you observe on a website. I'll make it very simple. Formula of sample size depends on methodology or type of sample you have selected. So there is no any textbook says that this is a method of sample size calculation. So don't try to hunt for it. Once again, the formula of sample size depends on methodology and type of sample you have selected. And even statistical test you have decided. So if you have a test, if you have decided, it will also have an impact of on your sample size calculation. Formula of sample size estimation is depending on prevalence of the disease or prevalence of certain areas you are interested. The result of your pilot study or assuming mean or allowance of error. So there is a three-way you can design or plan your sample size. One is a rate of prevalence, the result of pilot study, minimum 30 sample size. You draw the study, and then based on your study and error what you observe, you can decide sample size, or assuming mean or allowance of error, and then you take a sample size. Higher the level of significance, if you set the level of significance 001 or confidence interval 99%, higher the sample size you require. Once again, we need to fix our level of significance when we decide our methodology, not just during the study if we get 0.001 and we continue with it. You should know that level of significance well before. Confidence interval, we have a very different practice where the scholar keep the 95% confidence interval. It's not needed always. You can have a 90, 90, 80, 85% of confidence interval. You accept certain error to be possible in your study. So to tighten the confidence interval and level of significance require higher the sample size. As range of standard deviation goes broader from your pilot study, your sample size goes higher. So there are the wonderful softwares are available where you, from your pilot study, if you have a standard deviation of plus and minus 4, then it depends that your sample size goes higher. If accept the higher errors, in case of without pilot study, the sample size goes higher. Example, you want higher error, like somebody takes the BP, checking the blood pressure of 100 people, and if you have a accept that error could be plus and minus 4, 120 plus 124 and 116 could be error, then definitely you require higher sample size. Rate of occurrence also increase, you require higher sample size. But nothing wrong about it. You can set your data and accept that the rate of occurrence or error or confidence interval in your study. You make the things very clear. You have set the level of significance 0.05, and based on that you decide the sample size. Let's have one activity. I'll play one video about test of normality. It's also a very common thing. People have many questions about how to decide the sample size, how to decide the test for my data. So normality test of normality test is data normal distribution of data, and it's commonly the guiding path to decide parametric test or non-parametric test. Remember that parametric tests are much more focused on mean specific, and non-parametric tests are focused on median. Let's have first understand from the one video. These videos are in support for SPSS and available on website. I'm going to play the video.
Normality test using SPSS. How to check whether data are normally distributed. As you know, in many statistical analysis, there are dependent variables and independent variables. A dependent variable is a variable that may depend on other factors. For example, exam scores as a variable may change depending on the student's gender. An independent variable, on the other hand, is a variable that doesn't change. For example, gender doesn't change depending on exam scores. Many parametric statistical methods require that the dependent variable is approximately normally distributed for each category of the independent variable. The normal curve is the familiar classic bell-shaped curve. In our example, exam scores need to be approximately normally distributed for both males and females. Let's use SPSS to verify this. We must investigate the following numerical and visual outputs. The skewness and kurtosis Z values should be somewhere in the span of minus 1.96 to plus 1.96. The Shapiro-Wilk p-value should be above 0.05. The histograms, normal QQ plots and box plots should visually indicate that our data are approximately normally distributed. Remember that your data doesn't have to be perfectly normally distributed. The main thing here is that they are approximately normally distributed, and that you check each category of the data are approximately normal.
Here I would like to emphasize this is a method being taken by the following numerical and visual outputs must be investigated to decide the data are normally distributed. There is a three method: skewness and kurtosis, Shapiro-Wilk test, and histogram, normal QQ plot, and box plot. So there is a three different method to identify your data are not distributed normally or not. The reason why we are discussing this because the most of data is what we take and we select the method of statistics may always you find there is a wrong selection of the study. Data are not normally distributed and then we take parametric test. Means data are normally distributed, we can take parametric test. And data are not normally distributed, we can take non-parametric test. Many times you observe that people take the non-parametric test and they use the tables with mean difference. Now, non-parametric tests are based on median and parametric tests are based on mean. So you cannot show that certain values of mean when you have used non-parametric test. The objective of this video to understand that the method to decide normal distribution of your data. So once again there is a three method. Skewness, the data are tilting. If the normal curve, it is tilting in a one side. Means if it is a mean but number are away from the mean. It is rarely possible to have a mean, mode and median at one place. It always you find they are skewed somewhere. But data away from the mean, it matters a lot. And kurtosis, it is higher, how much they have spread, it is kurtosis. Second thing is a Shapiro-Wilk test, the p-value. And histogram, normal QQ plotting is a visual thing. Let's have this video and understand. You need to excuse me about some quality of sound, but you try to read from the words.
Distributed. Remember that your data doesn't have to be perfectly normally distributed. The main thing here is that they are approximately normally distributed, and that you check each category of the independent variable. In our example, we must check both male and female data. Now I will show you how to do it with the help of SPSS. Afterwards, I will provide references and show examples of how you can write out your results in your paper or article manuscript. In the SPSS menu, click on Analyze and select Descriptive Statistics, then Explore. In our example, exam scores is the dependent variable because, as I said, we assume that they may change depending on gender, and gender is our independent variable. Next, click on Plots and select Histogram. You don't need stem and leaf. Select Normality Plots with Tests and continue. Click OK to execute and generate the output. First, focus on skewness and kurtosis. The measures are in the left column and their standard errors are in the right column. The skewness and kurtosis measures should be as close to zero as possible in SPSS. In reality, however, data are often skewed and kurtotic, as you know. A small departure from zero is therefore no problem, as long as the measures aren't too large compared to their standard errors. As a consequence, you must divide the measure by its standard error, and you need to do this by hand using a calculator. This will give you the Z value, which, as I said, should be somewhere between minus 1.96 and plus 1.96. Let us start with the males in our example. To calculate the skewness Z value, divide the skewness measure by its standard error. Here it is 1.02. This value, 1.02, is neither below minus 1.96 nor above plus 1.96, which is exactly what we want. Next, calculate the kurtosis Z value for the males. In this example, it is 0.81, which is also within plus minus 1.96. Next, calculate the skewness and kurtosis Z values for the female data. It is minus 0.03 and minus 1.16. All four Z values in our example are within plus minus 1.96. Hence, we end this part about skewness and kurtosis by concluding that the exam score data are a little skewed and kurtotic for both males and females, but they don't differ significantly from normality. Next, let us focus on the Shapiro-Wilk test statistic. The null hypothesis for this test of normality is that the data are normally distributed. The null hypothesis is rejected if the p-value is below 0.05. In SPSS output, the p-value is labeled SIG. In our example, the p-value for males, 0.456, and females, 0.493, are both above 0.05. So we keep the null hypothesis. The Shapiro-Wilk test thus indicates that our example data are approximately normally distributed. Next, let us look at the graphical figures for both males and female data. Start by inspecting the histograms visually. They should have the approximate shape of a normal curve, and I think they have in our example. So everything is okay here. Then look at the normal QQ plot. The dots should be along the line. This indicates that the data are approximately normally distributed. In our example, I think they are approximately distributed along the line, so it's okay. Skip the detrended QQ plots, you don't need them. Look at the box plots, they should be approximately symmetrical. Although they are not perfectly symmetrical in our example, I think they are good enough. Finally, before I show you how to write out your results, let me provide the sources. These are the books and articles that are the basis for this tutorial. This is
So it is all about available free YouTube video what you have seen about how to decide normality of data. And I request that all those researchers, the resources are available online. It is a matter of how much time you are spending time with me here. Sometimes just read some of the YouTube videos about statistics. You will find definitely interest out of it. There are hundreds of softwares are available. One among all, it is SPSS, which I found comfortable. But there are MATLAB and Statecraft, number of things. And it is not difficult at all. Just requires a matter of some practice. Let's have one activity, we do one more thing. We have a data. I hope that you are able to see able to see my screen here. Maybe the fonts are little less. What you are seeing is the screen of SPSS. Okay, here I have kept the two data. COVID cases at present date and test done. Number of tests done and number of active COVID case at present today morning in Gujarat. I would like to identify, is there any correlation between the test done and active case observed? Means that if thus the increasing the test will increase the active cases, just put the data on your SPSS, go to analyze. Now entire this what you are seeing that it is a self-learnable. You can download the one software, you can practice and you can learn a lot from this. Example, I do correlation. I do bivariate correlation. I take this both the data on variable and I analyze for Pearson correlation. And what would I observe here? That correlation between active COVID cases and test done, it is a highly significant, two-tail significance, 0.922. It is a correlation. That means increasing in a test will increase the active case of COVID-19. This you can see once again what I have mentioned here. The test done so far mean and it is a came positive. At 1000 cases, 85 cases are finding positive. But there are a number of things you can practice in your lay time to learn about these softwares available. I am not advocating any software, but they are the freely available. You can pick up any of them. This is a graphical thing what you observe. These also are prepared on online. It is freely available. Means the same data. Example, you have a data. You can prepare. Go to graph chart builder. Here you can select the if I want to take a scatter graph, then double click which graph you have selected. I am sure that you have a difficulty in viewing this, but you can take all this tutorial available on site. You can select y-axis and x-axis and you can prepare the graph. Double click on graph and you can have a midline. And this is a way you can put those lines in your presentation. So here probably when we do the face-to-face lecture, we always prefer to have a hands-on practical. But here you need to excuse me, but I'm trying myself that computing in statistics is not so easy. I have learned and you definitely can learn better than me. It is just require some practice session and all the learning resources are available freely online. We also have one analysis I have prepared here about repeated measure ANOVA, rate of prevalence of COVID-19 in Gujarat. Significant constant changes observed in increasing in COVID-19 from 10th of April to 25th of April. I'll try once again if you can see in the quality of your screen. Then it's okay. Repeated measure ANOVA. I have just prepared the rate of, I just speak. Control. Okay. Thanks my friend, my assistant, my friend is helping me out to enlarge. But there is a data in Ahmedabad, Surat, Baroda. On 10th of April, example in Ahmedabad there is 150 patients were there. On 17th of April, active case were 590. And 20th of April, it was 1200. and 22nd April it is 1400, and 25th April today it is 1800. If I have a data of all the cities of Gujarat, and then I want to identify that does this constant is significant or non-significant, means the prevalence is happening on 10th or 15th, and how this rate of prevalence is going out of it. I just can take the one of the analysis called repeated measure ANOVA, which is help me to understand how data are analyzing. I can select the factor, the example, the rate of prevalence. Then if it is a 5, we have a 5 categories, and I go with it. It is I'm sure you have a difficulty of watching this, but just I'm trying to do that. It is not difficult in analysis. Then even you can go for option, and you can select some of the areas. Settings are available, and we can find out. Here you can see that how all 4 sample on 10th of April, 15th of April, 17th of April, those active cases those arrived in Gujarat are constant. It has been seen by Wilks lambda test. It is a multivariate test. You observe that it is not significant. That means there is there is constant change you observe throughout those days. If you really ask me that how the trend, how the prevalence, how the case are coming very statistically prepared. It is not just only the test has taken, but this is a mode where all those 5 days you observe there is a constantly increasing in active cases in a current or recurrent mode. So the types of data mining and analysis. There is a 2 type. Is retrospective data and prospective data. Let's go with data mining and analysis. Data mining is the process of analyzing the large data set. It's a big data, very much famous terminology. Data scientist, big data, data learning. From different perspective and uncovering the correlation and pattern to summarize them into useful information. Nowadays, it is blended with many techniques such as artificial intelligence, statistics, data science, database theory, and machine learning. Data mining was recognized as a sub-process or a step within a larger process called knowledge discovery database. The main focus of data mining was tabular data. However, with the evolving technology and different need, new sources were found to be mined. Text mining has come, image mining and graph mining. Image mining, probably you know about Google Picture. Text mining, you know about all those Orkun, Turnitin. They can identify the which data from where. Now big data, it is a data mining paradigm. Verification and discovery is a 2 section in the data mining paradigm. In discovery, we have a prediction and description. And prediction, then we have a regression and classification. You must be wondering that where this lecture, what we are trying to explain here, but it is all about data, is information. Now, the data, retrospective data are properly analyzed and it predicts some kind of information. It is called prediction, regression. And with the present situation and past, it gets some information to the public. It is all about big data. I'm sure that next few slides you'll understand about what is a big data. What is the use of big data or data mining and analysis? Identifying the consumers in e-commerce, recommending the product, analyzing the review. If it is a manufacturing, predicting the potential problem, monitoring the system, automating manufacturing unit. If it is a banking, The big data, retrospective data with present prospective data, it helps to identify fraud detection, credit risk modeling, customer lifetime value. In a healthcare, medical image analysis, drug discovery, bioinformatics, and virtual assistants. If you remember that before 15 years, there were so many data being tracked under medical discrepancy. If you give one file of patients, people used to pay 500 rupees. And all the data transcription happened. People have taken those retrospective data and they have come with the new medicines. They come with the new technique. They understood the entire medical science with retrospective data. How the patient has improved. So those informations have given a very good platform for learning without doing any lab-based research. So healthcare is one of the area this retrospective data helps a lot. Transport, self-driving cars, enhanced driving experience, car monitoring system, enhancing the safety of passengers, all are based on retrospective data. Finance, it is also having a risk analysis, algorithm trading, strategic decision making, and customer segmentation. Also having a data mining. The objective of discussing this all, it is about importance of the data as information. And you cannot process the data without use of computing. And here, I would like to share one of the very lively experience of me and my PhD scholar, Professor Ashish Kakkad, about big data. What did I say about production from my research work? You can see the next to me, it is Professor Ashish Kakkad and some of my very good senior and colleagues. This is a trip what we had in last month at Chennai. I'm just trying to share our experience. We have prepared one predictive model, which is based on computing in data mining and analysis. So this is one live case for your study. To understand the process of data mining analysis, we have prepared the stroke recovery predictor. It is a Google app. What you can see on your right side, it is one of the Google app where when you enter some data, you can predict the patient's recovery. This predictive model was prepared to know the status of recovery of patient with hemiplegia, the stroke, those who get brain stroke, and after they get brain stroke after 1 month, 2 months and 3 months, if they want to know how much they have recovered functionally, they have recovered, that can be identified by this application. But the developing this application having a very good backup from data mining and analysis. This is one of the picture of the mobile application where certain information you have to put, date of admission, date of discharge, the type of stroke, it is hemorrhagic, ischemic, recovery on a date, so date of admission and date of recovery. I am sure you must be able to understand that the amount of time you have spent inside the hospital can increase your recovery time. Means if you have spent 5 days in hospital, then we analyze your predictive model of 100 patients, which increase the time in hospital, increase the recovery as a stroke patient also. If the type of stroke, if stroke is hemorrhagic or ischemic, hemorrhagic people having a more time required for recovery. So this application had a lot of brainstorming work under the big data, predictive analysis of those data. And you get the score. You're supposed to have a score, your actual score. After 2 months of having a stroke, someone take the score. It was a functional score, it's called Fugel-Meyer assessment. You can download this application freely available. So after 3 months of after the 3 months of the stroke, hemorrhage or infarct, if we check the functional assessment and person gets score in that questionnaires, example 50 score. And with this application, we also can find out expected score. So person recovery is a 50, and expected score is a 60. That means it is a having a less recovery than expected as per the this application. So this is a base on that. So what exactly we have done in this data mining? So retrospectively, what you can see the retrospectively data, we have developed the stroke predictive model by analyzing the past data record of the patient with the stroke, hemiplegic patients, and we have associates them with their status of recovery. Those people who had a stroke and what is the backup history from the hospitals we have taken, and after that those factors, how they have recovered in the future. With those information, we have prepared the one model, and that model we have tested with prospective data. Prospective data means what? We have taken some more subjects, another people, new people, and we have taken with those stroke people and compared their values in this predictor application and as per their actual value of prediction, and we observe that how much they have improved, and we have tested and we found that our prediction and actual score of the patients we found based on sensitivity and specificity. So I'll have a small glimpse of this experience to help you to understand. So I'll go with very bird view. We have taken hemiplegic people. We have identified some factors which is responsible and appears under the patient with the stroke. We have taken a consensus about the factors. Factors are the age, the type of strokes and all. Regression analysis for retrospective model was done. Development of predictive model. Model was developed based on the regression analysis. Again, computing and statistics are part of it. Then collection of prospective data. Then prospective data got collected and tested, compared the actual score with the model score, and analyzed the sensitivity, specificity, and overall accuracy. So these are the factors we have taken. How much time? Okay. Okay. So we have a phase-wise study we have done, and we had 111 subjects, and this is about phase 1 when we identified the factor responsible for having a stroke and significantly for having a recovery as impact. Linear regression at confidence level what capped on 90%, and different predictive factors and post-stroke recovery was analyzed. I have a video been prepared by a very good friend of mine, Professor Ashish Kakkad, but because of time constraint, I am not presenting here. This is a coefficient. What you can see in a green color, the type of stroke, it was a significant effect, 0.043, and length of staying in hospital. These areas were highlighted, even the post-stroke duration. After the stroke, how many time, how long they have stayed in hospital. So if you see that thing, the type of stroke, length of staying in hospital, and post-stroke duration. If it is after 3 months or 4 months, patient is coming and we are testing them, it is having the impact on recovery of the patient. So these factors been taken. This is a formula has been prepared. Formula based on this model and converted this formula in application. So there is a values are mentioned here, and it has been gives the result about the model based score of Fugel-Meyer. For Fugel-Meyer. Sorry. Yeah, correct. So that is phase 2. We have compared with this, and then we identified that prospective study and retrospective study data, what is association with each other, and we observed that based on the coding that it was a sensitivity was 29%, specificity was 98%. The proportion of people with prospective positive and negative result was higher than 93%. Overall accuracy was 69%. So it was a model, predictive model we have prepared and we have tested. And this is what you see in a, and definitely I prefer that you can check this Google app is the name of stroke recovery predictor. It is one of the big data analysis, and I'm surprised that we came to know that what we did in a prediction analysis, it is called big data analysis, and computing was one of the key factor of learning analyzing this tool. If we do not learn the statistical software and statistical method, then data mining and analysis will be difficult for us. We cannot just lay the information responsibility to the statistician who will not understand always your objective of your studies. I'm glad to say this the picture of copyright. Even after we prepared this software, we got copyright from government of India. It's all thank you very much for all those people who are supported for entire process. Once again, thank you very much for listening me. Here I am finishing my session. I am sure you must be having many doubts, many questions, but in a short span, I would like to showcase the use of computing, the software application in data analysis and mining. So if you data mining and analysis, retrospective data and prospective data, you can do amazing research. It will be help you a lot for prediction. You can note my email ID and you can mail me for any questions you have. We have a question session now. Can we get the PPT? Sure, you will get the PPT. You will get entire presentation. You get entire presentation on YouTube. What is the confidence interval? I didn't get. Confidence interval, I think, my friend, it is a 95. If you're expecting the 100%, you are assuming that 95% will have a change. So you keep that 5% could have an error. I think this is the most easiest way I can explain about confidence interval. You set the confidence interval well in advance, which is a good software for analysis. I said there hundreds of softwares are available. Don't become one of it. What I have presented here, it is SPSS. I am using the trial version of this application. There are a number of applications available, but believe me, it takes at least 10 or 5 days of time to learn from the tutorials. The videos are freely available. You can see the videos, you can practice and use the applications. Another question, right now we have a lot of data generating research. So is not it important to have a data which is globally significant? When you talk about, see, that is, I'm totally agree with you that the same kind of data is happening worldwide. But in India, we have a clinical trial registry. If you are doing one research in one area and same kind of research is happening in another part of the India, you can come to know by the registry of those research. And then you can communicate with the person and you can minimize unnecessary expensive or efforts to do those research. Can we use G power to estimate sample size? I think definitely you can use G power to estimate the sample size. But my dear friends, I will put it in a very simple way. What is the sample size we have to understand? And selecting the sample size, your statistical knowledge is very important thing. So better to get into the software knowledge together with the basic knowledge about statistics together. SPSS is a paid software. Can you recommend a free software? Very nice. There are the number of softwares are available, and just I don't recommend any one. You can just search on online. Even Google app having hundreds of softwares available. Why particular Z value is 1.96? Z value is 1.96 means if you have a mean, if your data are distributed in a both the side of your mean, okay, if your mean is a 50, you have a 0 to 49 and 51 to 100 in both the side, so near to the mean you have a 32% example, and then 64 percentage. And those who have extreme data, it is come in a Z value, that is called 1.96. So it is all about, I want you to see the one bale of normal distribution curve, and you understand what is 1.96. How to do normality test. Exactly that video what I have said is available online, and I said about there is a three methods: kurtosis and skewness, second is the Sapir-Whorf test, and third is observational method. Before 20 years we used to use another method. It was called the mean, mode and median. If they comes together near to each other, out of two parameters, if it's mean and median or median and mode, we used to consider as the data are normally distributed. But now we have a software support to identify the normality test. So based on the latest available resource of skewness and kurtosis and Sapir-Whorf test and observation of the graph, either three, you can take two positive, they're falling in a right criteria, you can justify the data are normally distributed or not. It is again not needed that all the data are normally distributed, but definitely we always try to take the data in a medical science and quality research who are normally distributed. But epidemiological study, you always find data are not normally distributed. Can we use only a dimension to set sample size, or need to use all three dimensions to set sample size? Totally agree. You can decide before if you have decided one study, think about the sample size first, because sample size will increase the cost of your study. So you have to, if you have a higher quality, if you keep the low error, then you have to have a higher sample size. If you keep narrow sample size, narrow standard deviation, you have a higher sample size. If you want level of significance 99%, 0.0001%, you large sample size you needed. So first of all, you fix the level of significance, confidence interval, and error what we are expecting. Why are the Sapir-Whorf is before 0.05%? Agree. So it is all about, out of, I'm just put it in a very layman's language, if it is 100 out of 5, means probability of 5 people do not change out of 100, then is 0.05. I think that is a way you can understand what you mean by 0.05. Why is different between the logistic regression and discriminant analysis? What is the difference? Logistic regression is between the two parameters and multi-parameters, but discriminant analysis comes out of this logistic regression. So discriminant analysis comes out of logistic regression. There is a totally difference between the two analyses. I'll take the last question. SPSS. Okay, fine. That is one question. How classification can be used for prediction? I think those who are interested in specifically in big data analysis, there is a call classification comes under prediction. And as I said, there is a multifactorial use of data mining. So those retrospective data. So I think it is a matter of interest. It comes in a classification. Like clustering, it is also classification. So I think it's very broad application of data big data application. So I request that the person who asks questions to get into more available resource online. Once again, thank you very much. There are the many questions. Probably I'll answer. On a YouTube available, or you can email me for the same context. Thank you very much for such kind of exchange. And stay happy, stay healthy, and stay home. Over to Professor Devang Pandya.
Yes, thank you very much, sir, for this really wonderful lecture regarding computing and data mining. These are some of the things that the researchers from medical and paramedical field are not very well versed with. So thank you for simplifying things for us. It has been a wonderful interactive session as well. Lots of questions coming in, and I hope they keep coming in for the next few days as well. So we end the day over here. Thank you, sir, and thank you all the participants. We will be back tomorrow for day 4 at the same timings. Tomorrow we'll be looking into some more statistical analysis of our research, and then we will try to understand the various metrics of the journals like impact factor, site score, H index, and go on to identify a good journal for publishing our work. Good night, stay safe, see you tomorrow. Thank you.